Good morning and welcome back, everyone. It's great to see you here again. I have muted all of you, but I'm going to start now with some introductions. I would like to, introduce Adrian Barfield. In today's session, we are going to hear from him. He's from the i2 group. Adrian has worked in IT for 36 years, spanning a range of careers in product development and management, technical support, technical sales, marketing, training, sales, and channel management. For half of that time, Adrian has focused on solutions relating to combating fraud and criminal activities and providing public safety. He's based in Australia and for the last 12 years has been performing consultancy using the i2 product set and working with leading banks, law enforcement, defense, and government agencies in order to strengthen their abilities to detect and investigate bad people doing bad things. For those of you who haven't heard of i2, it's the leading link analysis software in the marketplace, has been evolving since its creation 30 years ago, and is used across a wide variety of use cases where people are performing investigations and analysis across a wide variety of data sets and are trying to pinpoint necessary details or complex patterns. So today, Adrian's going to talk about how i2 is used within a variety of customer types around financial fraud. Over to you, Adrian.
Thank you very much, Samir, and thank you all for allowing me to spend some time with you today. Very much appreciated. I'm going to share my screen, Samir, if that's okay.
Yes, please go right ahead.
And right, I'm just trying to get my PowerPoint so you can see it. Right, can you see that?
Yes.
Fantastic. Okay. So we've got a whole hour today. Obviously, I'm going to leave some time at the end for you to do some questions and some answer some questions. Some of those for you. But as Samir said, I've been working in IT for over 36 years now. I know I don't look old enough, but that, all I can say, healthy living lifestyle. And most of that, well, at least half of that time has been spent with law enforcement, defense forces, commercial sector, looking at how to stop people from committing fraud, and where they have committed it, actually being able to find them, capture them, and prosecute them. So Samir mentioned very briefly, a bit of an overview of what i2 is. Now, if I'm going to give you the kind of the high-level spiel, it's basically a multi-dimensional data visualization and analysis set of tools. So that sounds incredibly impressive. I'm sure you'll agree. But what it really means is when we're looking at things where people are committing fraud, they're committing financial crimes, they are committing traditional crimes, they're doing things which we need to look at from a different set of perspectives. Sometimes we're looking at things, how things are connected. How do people relate to each other? Do they own accounts? Have those accounts transacted with each other? But we're also interested in temporal information. What order did things occur in? We're interested in the geography of things, and where did things actually occur? And if you imagine all the data sets that you might need to work with on a daily basis, they might be coming from flat files. You might need to pull them from a mainframe system. You might need to pull them from open source intelligence. They might be in a Word document or a PDF document. But all of those different data sources describe things differently. So if we can actually normalize all of these data sources and provide a common visualization, it's just something where, as humans, if we can see a pictorial representation of data, it makes it much easier for us to understand. And then we need to provide some analysis tools over the top, which allow us to understand exactly what's happening across all of these different data sets. So that's effectively what i2 is. And i2 has been out in the market, as Samir said, for quite some time. we were the first commercial link visualization platform. I just realized this said 1990, actually between 1990. Anyway, we're used by thousands of customers around the world. And at the end of last year, we were part of IBM, but we actually got spun out into our own organization by Harris Computer. And they're investing in us at a rate of knots. We've actually just bought another company ourselves, and I'll show you a little bit of that a bit later on. But you know, we've been around longer than anybody else in this market, and we're really progressing at a rate of knots at the moment in terms of product development and gaining more of the customer sector. Anyway, as I said, I2 is a way of being able to visualize data. And the way in which we visualize this is all around something we call an entity model or a data model. And we use three concepts: entities, links, and properties. And the reason we use this is that it can be used to describe absolutely anything in life. So if I give you a very generic example to start with, where you might have an individual, let's call him Mark Davis. And Mark is an entity, he's a person. An address would be an entity. Anything you can physically touch would be an entity. And as a person, there are details around Mark that we would normally look for. So we'd look to see his name, middle name, date of birth, ethnicity, nationality, hair color, whatever it may be that's of interest to us in our investigation around Mark. And we also kind of want to understand what things are related to Mark. So Mark might be married. His marriage would have had a date. So that link between Mark and his partner has a number of properties as well. He has a spouse who's called Mary Jane. And we can kind of see her date of birth as well. So we've got two entities with a number of properties and a relationship between them. But then we can kind of start looking at how they actually live their life. So maybe there's an event each morning where they wake up. So they've woken up, they both attended it, and there's a location where they live in the house, which is where they woke up. And you can kind of have that relationship to say that they both reside at that place. Maybe they then had breakfast, half an hour later. And then Mark gets in his car, he drives to work where he goes most days. He's an employee of that organization. We can also see that he's got a co-worker called Sarah Jenkins, and that these guys then attend a video conference call with Lucy and Ben, who are employed by a different company called Stratman Inc. So it builds out this relationship model of everything that we know about these individuals. And the importance of this is we can then start asking questions of these data models. So we can say, when was Mark born? Well, we've got that in the properties against the entity. Who was Mark Davis married to? Well, we can see that there's a marriage link to Mary Jane. Who does Mark Davis work with? When we go via his employer, we could see that he works with Sarah Jenkins. What did Mark do on the 3rd of August? Well, we can see that he attended multiple events. Does he know anybody at Stratman Inc? Well, yes, he's had a conference call with Lucy and Ben from Stratman Inc. So it's very easy to actually model the data in this format and then be able to ask any range of questions of it. Now, obviously, this is a little bit basic, but what we try to do is take that data model and then apply a set of visualizations and tools which make the analysis and the querying of all of that data much simpler than you might have to do if you were trying to work through data manually, a hell of a lot faster than you'd normally do, and more accurate in terms of being able to see a wider range of connectivity in the data sets than you'd normally find if you were trying to do things manually. As Samir said, we do this across a lot of industries, for everything from standard policing, where we'll be trying to do investigations into persons of interest, call data analysis from cell phones or from towers, but also obviously looking through financial records when you're trying to follow the proceeds of organized crime. We use this within government agencies such as tax departments, again, where we're looking at financial records and we're looking at non-compliance and serious non-compliance around tax concerns, and also working with JITSIC, where it's the international joint task forces between all the tax agencies. We look at defense forces, and then we look at all of the private sector things such as banks, insurance companies, anybody providing financial services, but other organizations who might be still under pressure from regulatory bodies such as gambling and casinos, or any form of monetary advice that might be going through, or wire transfers. You know, the list carries on. And when we're looking at these organizations, the sorts of data that they need to manage, the sorts of questions that they're asking are always going to be different. But for fraud and financial crimes, typically we're going to be looking at accounts, the account relationships, somebody a primary or a third-party signatory, telephone details, addresses, account holders, know your customer information, so all of the proof of identity stuff that people need to provide during an account application, transaction histories, email addresses, and we build this into a model which makes sense for financial fraud. So as far as fraud is concerned, I'm pretty sure that everybody knows that it's basically somebody who's deliberately trying to perform a set of tasks which would actually take money from a third party which does not belong to them. And when we're kind of going through that, the actual pattern of fraud that these perpetrators take is going to range. It could be identity theft, it could be the placement of skimming devices at point of sale or on ATMs, it could be fraud through telephone banking, could be application fraud, mortgage fraud, and all of these tend to relate more to banking, but it can relate to any other organization as well. Anything such as expense fraud, every organization probably sees it. Also, when it comes to awarding contracts to different vendors, any improper behavior or relationships such as bribery that might be going on. And this is something that through all of the more recent regulatory reports on banking, you'll see a much more focus on the bank's internal practices, where they've got to do due diligence not only on things such as traditional AML for their customers, but also introspectively making sure that all of their employees are performing against the correct guidelines and not doing stuff that they shouldn't. So with that said, let me kind of take you through how these sorts of tools are normally used. Normally, within any form of fraud investigation, there are a number of phases that you have to go through. You have to kind of acquire information. So that might be transaction logs, it may be that you're reading stuff, you're getting tip-offs, you're getting alerts from different detection platforms, but we need to acquire this data in some way, shape, or form. And then we look at ways to fuse this stuff together, because all of these different systems might have correlating pieces of information, but they're all in different formats and they're all described differently. So we need a way of being able to fuse this together. Then we need analysis tools, and then we need to be able to publish these things out. So if I'm finding something of concern, how do I actually let my colleagues know? How do I close off a case, which is an investigation? Sorry about that. How do I actually make sure that the people who need to do the next step in that investigation are aware of what I found out? So the way we do that is we have a couple of different mechanisms for working with data. One is that we can ingest data. That means that we take data from a variety of different places, we massage it, and then we put that into our own intelligence store. So maybe I'm taking ATM logs, I might be taking alerts from detection platforms. If I've previously investigated people, I might be taking investigation files, suspicious activity reports, details around my customers and bank accounts. And then there are things that I might want to connect to dynamically. I might not want to bring all of my financial transactions into I2, but I want to be able to talk to my transaction stores whenever I need to get a complete list of all the transactions. I might want to work with regulatory bodies or industry affiliates. In Australia, as an example, we have quite a few task forces between the banks and the federal police. And then there are going to be other financial institutions, such as all of the different banks that you need to share information with. And when we're doing an investigation, it's typically going to follow this sort of process where somebody gets an alert or a tip-off, something they need to investigate. And then we try to go through and build up a 360-degree view of exactly what's been happening. We formulate the results, and then we put our findings back into a report, which can be shared. So let me kind of actually show you what this looks like in tools. And I'm going to just go through a few little simple examples where we're going to ingest some data, we'll do some transaction analysis, and then we'll look at how some of the customers who are working more collaboratively would ingest data into one of our repositories. So hopefully you can now see my screen. And
yes, we can.
So this is what I was saying might look like a customer model to somebody who's going through fraud. What you can see on the screen at the moment is one of our tools. It's called Analyst Notebook. It's a desktop client into our platform. We've got web clients as well. I'll show you those in a bit. But what I am going to do is I'm going to start off with a blank sheet. And I've got a little sample file of transaction data here. I'm just going to do a small amount so it doesn't bring too much stuff onto the screen and makes it easier for you to see what's going on. So this is some pretty standard structured information where we've got an account holder, we've got the originating account, we've got beneficiary account details, we've got account types, we've got financial institutions, account numbers, currencies, the amount, the type of transaction, the date when it occurred, etc. There's a bunch of information in there. And what I'm going to do is I'm going to import that information through something called an import specification. And an import specification is something where an end user can create a library, or your teams of users can create a shared library of how to bring ad hoc data from a flat file into a visualization. I've got this one here called sample transaction data. And if I open that up, you can see that it brings the data from that flat file into a little wizard, which allows us to start visualizing that. And in this wizard, I'm just saying it's a comma separated file. And then I'm doing a little bit of cleanup to say that that first row of data actually contains column headings, which I want to be able to use during my import. There's a couple of rows of data which are relevant to me. And then I can go through. If I need to do any cleansing of the data, or I need to do transformation of the data, it allows the users to create some pretty simple rules. That it may be that you've got one data set where your address information is broken into address line 1, address line 2, address line 3, suburb, postcode, etc. And another one of your sources has just got it all in one field, and you're trying to normalize. So you want to merge data fields together. It may be you want to split data fields. I might want to have, in this case, I've created a couple of extra columns where I've taken the first column account holder, and you can see that I've just put a rule in there, which is extracting pot using separators, where I'm saying it's space, and the first one is just taking out the second part of that first column where it's after the space. The next column I've created is just taking out the first part of that. It could be that I want to strip out other characters, I want to normalize things, I might have things which I want to marry up against lists and normalize them against the kind of like a set of mandatory fields. So there's a lot of flexibility in this. Anyway, I can go through that, and then I get to say what I want this data model to look like. So I'm going to have an account holder with an account transacting with another account. And in order to populate this, I literally just drag and drop fields into these onto this kind of like little workspace in order to define how I want the things to be shown on the chart. I can add new entities if I wanted to. It's literally dragging and dropping things, adding new links, etc. And then if I just click on import, I don't want to make any changes. What it then does is it takes that flat file of information and creates a visualization for it. So here I can see I've got my user, Alex Kurtz there, and then I've got his account. So if I can just show this slightly differently, and we rearrange this. So put this into an organization chart. Yeah. So you can see that we've now got Alex at the top. And then as we go through, we've got Alex's account, and he has been transacting with all of these other accounts. And we can see the amount, we can see the dates when he transacted, and we can see the flow or the direction of this. That's a really easy way of being able to bring data in and start doing some form of analysis around it. What I'll do is I'll show you another chart over here. So here we've got a little bit more complexity in the data, still not a massive amount, and bear in mind that you might have thousands or tens of thousands of accounts and transactions showing up on some of these charts where you want to do analysis. I'm just trying to keep this pretty simple so that you can see everything on the screen in one go. Anyway, when we come in, we want to be able to analyze the data on the chart. So we've got a whole range of analysis tools which are available to us. I might want to break this down based upon account type, as an example. So I can see here on this chart, I've got a number of business accounts, some savings accounts, etc. I might want to look at things based upon the link types. So I've got a bunch of check transactions and credit card transactions. It's a nice, easy way of being able to filter things out. And these are all dynamic. So if I was to select business accounts, you'll see that all the business accounts on the chart get selected. And if I was just interested in those and those transactions, I could copy those off into a new chart and just focus on those. But in this particular instance, what I want to do is some transaction analysis. So I'm going to bring up this thing called List Most Connected, which is looking at all of the characteristics of the transactions on this chart. And one of the powers of i2 is that when we bring data into the visualization, it's not just a pretty picture. We're actually looking at every aspect of the data on the chart, not only in terms of the value of a transaction and the date of the time, but also the actual connectivity between all of the accounts and their relationship and distance from all the other accounts within this network that we can see on the chart. Because what we're interested in when we're doing financial transaction analysis is understanding the behavior of where transactions are going. Now, are we looking to try and find out the master beneficiary account after money has flowed through multiple intermediary accounts? Are we trying to identify mule accounts? Are we trying to understand how much money has flowed into an account versus out of an account? And this is where these sorts of tools make it very easy for us. So if I wanted to see the account which has got the most links, that means the most inbound and outbound transactions, I could click on most links. And then that will give me a little report down here saying this account here has got more links than any other account on that chart at the moment. If I was looking at the account with the most inbound transactions, I would go here. If I was looking for the most outbound, I'd go there. But I could also look at this from the actual values itself. So if I wanted to understand the total inbound money flowing into an account, then I could say that this account here, it's actually that account again, has got the most money flowing out of it. But I could actually say I'm interested in maybe the top 3 or 4. And I can select those and highlight those on my chart. I might want to then go off based upon the sort codes of these and talk to the respective financial institutions and get more details around them. And then they would provide me with a flat file of information, which I could import and overlay onto the existing information in this chart. I might be interested in something such as the total with low net change. So this is a really good indicator of a mule account, because we've got the same amount of money flowing in as we have flowing out, or there might be a small residual amount of money which remains in the account after each transaction. So this allows us to very quickly identify these sorts of behaviors. But we're not just interested in the transactions themselves, we're also interested in the other characteristics of the account, such as who the account holders are, where they live, who they've interacted with in the past. So if I was to kind of like show you a few other examples, so what I'll do is I'll show you how kind of a lot of other customers might work with this. I'm going to do something where the data has actually been loaded into our repository, and rather than me kind of doing a flat file import, I'm actually going to ask the repository to show me some stuff about somebody of interest. Maybe I'm doing an investigation into a person called Gene Hendricks. Yeah. So you could see there, really simple way of being able to search. And effectively what's happening at this point is it's going inside our repository, looking to see whether there's anybody of that name. It gives me some filtering options, and I can see that there's 5 records which contain stuff about Gene. There's a couple of charts which I've kind of pulled back in the past. Maybe I want to look at those. Or I can see there's one person. So I'm going to say, okay, I'm interested in that person, add them onto the chart. So I'm going to select them. So now we're not looking at an account, we're actually looking at a person. And I could say, well, I'm interested in the account information for that person. So I could do something where I say, go back into the repository and find me all of the details about their account. And what you can see, there's not just account information that we're pulling back, we're also pulling back stuff about addresses, their phone numbers, events they've been involved in, who their employer is, other people they're connected to. So I'm just going to say I'm interested in the account. And then it's actually brought back the account details for that individual. I might then be interested in understanding which account that has transacted with. So again, I can just say expand with conditions, and I can see that there's a number of accounts. I'm going to bring those onto a chart, and then that kind of brings the data back for me, and I can start looking at these transactions over a period of time. And that kind of brings us to a really good point, because when I was looking at these transactions here, when I was looking at these transactions here, I was looking at everything from a perspective of a link chart, but maybe I actually want to understand things from a temporal perspective. So it's very easy for us to actually look at these from a timeline. Maybe I want to go into this chart. I'm just going to show all. And what we'll do is we'll do an activity view. I'm just going to add all of those entities in there based on date and time. And it gives me almost like a Gantt chart view of when things occurred. And I can pivot between the accounts and see exactly when those things happened. That's one sort of temporal visualization. It could be that I want just to select everything on this chart and I want to do a timeline. So I'm just going to copy this, create a brand new chart from it. I'm going to put it into a timeline. And now I get a little time bar up the top. I can change this representation a little bit. We just arrange those. So now if I kind of jump down here, you can see that we've got all of the accounts down the side, and then we have the dates and times across the top. And this little line between these two shows that at that particular point in time, there was a flow of money, $4,000 from this account to that account. When we kind of go through the timeline, we can see in some instances where you have very short durations in between transactions. So we've got 50,000 going from this account up to that account, and then 48,000 coming out of that account down to this account. So that's kind of, I'm just leaving a smaller residual amount in there. And then that account straight away afterwards is taking 45,000 and putting it down to this account. So each of these accounts is just taking a little bit off the top as it moves the money through that network. So really easy way of being able to do that. And so I'm just going to kill that one. Don't want to save that. So we can actually visualize all of these transactions in slightly different ways and really quickly be able to see what's happening. But I don't always want to just take an entity and then keep expanding out and expanding out and expanding out, because if I was to show you what this looks like after a few expansions, you'll see that you end up getting quite a lot of data brought into the chart. And the more data you get into a chart, the more you have to spend time actually working through what's there. And as I said, this is all about providing you the way of being able to get efficiency in your investigations. So a lot of the time, what we try to do is allow you to do more of a targeted querying pattern across your data. Oops. Oh, there you go. Demo gods are not smiling on me this morning or this afternoon. It's just going to relaunch that a second. All right. So while that's just reloading quickly, I'll kind of just jump back to the presentation and we'll come back to that in a second. So that's kind of like some of the standard things you'd kind of see in fraud. And there's a whole range of use cases. We'll come back to some of these in a second. We might be looking at kind of trying to understand things from a geospatial perspective with skimming devices and doing geospatial overlays. We might be looking at application fraud. It's not always just used for fraud investigations. Sometimes if you kind of look at some of the banking customers, they'll also use this to monitor the behavior of their customers in order to work out which ATMs and which branches get used versus all of the other ones. And they'll use that from a best placement of branches and ATM devices, etc. But there's a lot of kind of flexibility in this. And when we're looking at situations such as money laundering, we try to kind of change the dynamic again, because in this particular instance, it's more of a numbers game. You're trying to get people to really get a view as to whether a person is a risk or an account is at risk as quickly as possible, rather than having to go through and ask lots of questions. So I'll actually show you some of how we do that now. Hopefully it's come back. There we go. Great. All right. So I kind of mentioned ATM locations and geospatial analysis. So here I might kind of run a query just to bring back some of my ATM devices. And I might want to understand which ones have been hit by skimming devices and understand where those things are. So we can actually apply geospatial analytics over this. And I've got a number of integrated mapping providers. So Esri is a common one that we use, could be MapInfo, MapLarge, OpenStreetMaps, Google Earth, whatever. But allows us to actually take data. So I've got a bunch of my ATMs and they've all got location information, and I can just throw them onto the map, just drag and drop. And it will put those in the correct locations. And you can see we're in Sydney, we're down at the rocks. I can kind of like zoom in, and as I kind of zoom in and out, you can see that it tries to declutter the view by overlaying these things on top of each other. And I could actually create rules within this to identify the things that are of interest to me. So as a fraud analyst who's working with ATM skimming devices, there are things that I might want to see. So if I kind of, let's just do it this way, style, conditional formatting pane. So I might want to have something which just shows me the skim devices. So it's a really kind of simple rule I've just created in here. Double click on that. And on the chart, it shows me all of the devices which have been skimmed in the past, also shows me those on the map. This is a really common practice that the banks would use if we're trying to understand the direction or the path or specific areas that groups are targeting. We use this for kind of lost cards as well, where you might have people going through mailboxes, stealing out cards they've been delivered to customers. There's a whole range for how our financial customers would actually be using this functionality. But anyway, what I was going to show you was how we can then start targeting things more directly. So I was just doing a simple search before, but in this instance, what I want to do is do something called a visual query. I want to look at very specific data patterns. I'm just logging in again. And we have this option here called visual query. And this basically takes the dynamic of visualization and spins it around. So whereas before I was showing pictures of the data that I've got, this time I want to draw a picture of the things that I want to find within the data model. I've got a couple which I've built out already. So this one as an example is just to try and show me anything which indicates a warning sign. So if I kind of open up this model here, you can see that as a customer, I might kind of like have accounts transacting with each other, and any of these accounts or the customer might have things such as an incident or a case file or an alert or something connected to them. If I look at this particular chart over here and we start looking at our data, there we go, we can see that our kind of person, Gene Hendricks, has got an account and he's been transacting with another account. That account itself has got an alert on it, and the person who's the owner has actually had a suspicious activity report filed on them in the past, and they've got an investigation folder. Now, if I kind of start running queries and expanding out, I can see these things, but I don't really want to do that for all of my customers. I actually want to be able to look for things and be alerted when these sorts of things occur. So when I'm running that visual query, what I've basically said is I am interested in people who have accounts connected to other accounts where there is any indication of a warning sign, which could be a SAR, it could be a previous investigation, it could be an alert, and I could run that. And then it will bring me back the results set. So that's now going into the repository of information and just finding things which match that pattern of connectivity. It could be that I want to be doing this within a specific region. So I could actually kind of do something very similar And when I'm editing my design, in this particular instance, I want to find stuff where the warning signs are within a particular location. And so when I say okay to that, I could then go through and say in this geographic area, and you can see that I've just drawn a polygon all around New Delhi. So I can actually kind of take geospatial capabilities and temporal capabilities and connectivity capabilities, and I can generate all of these things. And then when I save these, I can actually say, you know what? I want to receive alerts when the results change. So any new data that comes in, which matches these patterns, I want to be alerted on. So it may be that I'm running an investigation and I just want to get the updates on anybody who I'm interested in. Maybe I want to focus this onto Gene Hendricks, or I want to focus this onto David Yoakum and just understand when stuff around them changes. It's all about my criteria, or I could leave it very generic like this and just say, tell me anytime anything like this happens within this region. So very powerful set of capabilities. Anyway, so that's how you'd actually start navigating this thing. But say for AML, a lot of the time, we just want a simpler way of being able to look at the data. And in those situations, the users would typically come in and they might start off with something where they just log into their web client. They've probably got a case management system, which is delivering them all of the things that they need to investigate each day. And when they kind of come in, they can run a query for the person of interest. So I'm just going to do a query for my mate Gene Hendricks again. And we're just going to look at the person. And then we will copy into the chart. So all of the time here, I'm kind of just pulling data in from my repository. But it's also important to remember that when I'm running these queries, I can equally run them against external data. So a lot of the financial institutions will use sources such as Bureau van Dijk, WorldCheck in order to wash against their customer lists. You might be going out to sources such as social media, and we've got connectors which talk to over 130 social media platforms. We've got connectors which go out to different intelligence databases, and we've got a toolkit which allows you to build connectors into any of your own data sets. So if you've got your own databases, your own data warehouses, you can actually dynamically query data just using these simple searches. So anyway, there's the person that we've got of interest, and I just want to create a report on this person on the fly. I just want to understand everything that is of relevance to that individual. So rather than going in and exploring and expanding out, what I wanted to do is look at the data model, and then knowing that an AML person is interested in criminal associates, suspicious activity reports, they're interested in money laundering activities, they're interested in connections to known people who are politically exposed persons, whatever it may be. We can actually build all of that into one view so the person doesn't need to go exploring. Everything is brought for them straight away, and they can just go in here, and then if they want to run create a little report on that, then it just goes through, brings all the data together and generates a little report for them, which gives them all the kind of the screenshots, all the data that's listed out. So it's a much quicker way for somebody to be able to pull back some intelligence across all of the transactions, all of the connections with other people that they might be interested in. That is a really quick whirlwind tour of how kind of customers would typically use it. And as I said before, it's not just going to be banks who are using this. It's anybody with any obligation to do reporting around money laundering or investigate fraud within their own organization. If I can look at a couple of customers that I've done some projects with, we had a medical insurer. They were being hit by credit card fraud when we first talked to them. And we kind of did a bit of a pilot for the software. But when we kind of went through and did this, we got such great results. They immediately rolled it out, and we're using it to look at both member fraud and provider fraud. Tabcorp, they're a gambling establishment. They do shopfront betting shops. They also do these machines, which you get in a lot of pubs across Australia. And they had very different use cases. Medical insurance with member fraud, it was people who were taking out policies, and then they were trying to max out all the claim benefits on these things as quickly as possible. But when we look at provider fraud, it's far more complicated because of the complexity in claiming against any form of services provided. Dental fraud is probably the biggest one that they face, because if you have ever been to the dentist, you will know that they will give you sometimes a short consultation, sometimes it will be a longer consultation. You might need to have crowns fitted, you might need to have a scrape and polish, you might need to have fillings. Every single procedure has different claim codes associated to it. That person really wants to talk to me. And we had situations where we were seeing providers using this complexity to their benefit to try and hide their ill-gotten processes. And you'd see collusion between customers and providers, where maybe somebody's come in and they've had 155 teeth removed over a period of 2 years. Or we might have providers who are seeing families on a weekly basis or a monthly basis, including a 3-month-old child, and charging for it. When we look at the gambling side of things, again, you saw situations where it's rife for money laundering. Basically, people could come in with a stolen card, they could tap it against one of the kiosks, they could start making some low value bets, and wherever they won money, they could take that out. But typically what they would do is they would credit an auto-generated account on these devices and keep topping it up with more funds, and they take it out as a voucher and then give the voucher code to somebody else, and then they would withdraw the money from a different venue. And so you'd have all of these complex environments where we're trying to understand the depositing, the withdrawals, the geospatial location, the time between the deposits and the withdrawals, and have to kind of work through all of this data near real time so that things could be stopped in their tracks before more and more fraud was being perpetrated. Anyway, just to kind of give you some of the key value propositions as we wrap up today. These tools really have a number of key value points. One of them is efficiency savings. The amount of time that it takes people to run their investigations using these sorts of tools is massively decreased based upon manual evaluation of data, manipulation of data, and then analysis of the data. It can be anything between 40 and 90%, depending on the sorts of data sets and the analysis that needs to be performed. But because our customers get to do things much faster, it means that whereas in the past they'd normally have clip levels at a level where they could actually keep up with the workload, it means that they can actually reduce the clip levels of the fraud amounts, and they can do more and save themselves more over a period of time. because we provide better insight between the connectivity of different data sets coming in, it means that we actually capture more. We can actually track the relationships more. We can actually see where the patterns are occurring, maybe in completely disconnected sets of data, but the patterns are the same in terms of the behavior. And because we're using the same sorts of tools and we can enforce the same sort of rules, it means you get much better consistency in the way in which people are working through their investigations. So when you get consistency, you get efficiency. When you get the end product, it's going to have a lot more detail in it, which allows you to improve your entire fraud investigation process. And just to close out, if you want to know any more, you obviously all know Samir. Samir has been working with i2 for quite a long time as well. But Samir can actually organize any additional questions and answers. We've got a few minutes for some Q&A. I said I'd give you a bit more time than I've actually done. But we can kind of do much more of an in-depth demonstration, provide you access to trial licenses of the software, any quotes that you might need. We also run some little tips and tricks sessions. If you go onto our website, i2group.com, you'll see that we run these things monthly, free to join. You just need to subscribe, and it actually talks through different scenarios each time, gives you some tips and tricks about how to best use the tools. And with that, I'm going to stop talking and see if there are any questions.
Excellent. Thank you, Adrian. This was really insightful and useful. I'm sure there would be some questions. If not, I have some. But I think maybe you can, stop the presentation so that we can have people on the screen. Perfect. Thank you. Okay, so while we wait, we have a lot of these terror funding kind of situations. We also have currently what is really hot here are, these app frauds. We have applications, which people download from the Google Store and the App Store, and they install it. And then they apply for a quick loan, with minimal paperwork. So when they apply, say they're applying for, say, 10,000 rupees. So their sanction says 6,300 rupees or whatever. And 3 days into the loan, post the loan, they start being harassed to return the money, and they're supposed to return hundreds of thousands of rupees back, for just taking a loan of 6,000 bucks. When these are investigated, these tend to, end up at some Chinese directors and things like that, and connected to a lot of other apps and things like that. So do you think we could use the Analyst Notebook for that?
Absolutely, really good question, Samir. So this kind of comes back to the sorts of data that you want to investigate. It's not standard transaction fraud, but this is looking at fraud from a completely different dynamic, where we need to look at information about the apps. So you might need to work in collusion with the Google Plays or whoever in order to understand who's downloaded these applications over a period of time. You might want to look at the individuals as part of that organization who are actually creating these applications. So you might want to look at data sets such as Bureau van Dijk, where they collect the organizational structure information for all the organizations around the world, so that we can understand who the directors of that organization are and which other organizations they may be affiliated to. We might want to look at the account transactions coming on those particular individuals who have been affected. So you typically need to work with the multiple financial institutions who are actually paying the money. So this is all about investigation, and this is where the kind of tools come in. It's all about piecing together the information coming from a variety of different places and trying to provide the connection between it. And for each of those data points, there are probably going to be multiple things that need to be assimilated into your data model for analysis. But this is kind of like more of a law enforcement style investigation where they get involved and be working with a wide range of people. There'd be potentially witness statements as well. One of the tools that we bought recently was a natural language processing capability. So where people have given information to law enforcement saying these are the things that actually occurred over a period of time. I downloaded this app on this particular day. I got this email on this particular day. Our tools will actually read all of that and build up the data model in the same way as if it was coming from a structured data source. And so law enforcement would take the information from those transcripts, they build it out their data model with the emails, the transactions that occurred. They might look at the IP addresses that were used by the customer. They look at if they can start doing some network traffic analysis. We've got a complete cyber framework within the i2 stack where we can start looking at the traffic between the apps and the online provider of the service. So we can really go down to the nuts and bolts of exactly what's been happening over a period of time.
Nice. I have another question here. This is from Mr. Bhushan Ghode. He says, are forensic auditing and financial auditing the same thing?
Well, same, but different. So I guess with when it's coming down to the financial auditing, then it does tend to be very much more focused around the financial elements. If you're kind of really going down to forensic, then I'd say that you can actually take a lot more data sets in. So, just to come back to your example, Samir, where you were talking about the handsets where they've downloaded an application. That handset might have suddenly been infected with malware. There may be information which is sucked off from that handset. So we might actually want to take the handset itself and rip all of the information off. So if you're like a forensic auditor for a police station and you want to take all of that information and load it in with all the transaction analysis, or you want to look at the network traffic, then we're really getting down into data forensics and device forensics, as well as transaction analysis. So forensic auditing, I think, can be used interchangeably with financial transaction auditing, but it can also be extended out to a much wider range of data sources and techniques to look at the information.
Excellent. We have Mr. Vikas Razdan. He also would like to ask a question. But I think his question was related to how cryptocurrency transactions can be, investigated using the analyst.
Yeah, well, effectively, if you're kind of looking at blockchain, then there's a number of things which, are effectively just events as far as we're concerned. So if we're looking at a cryptocurrency wallet, we'll be looking at how transactions have occurred across a period of time, break those out into events, look at things from a timeline perspective, see the overall activity of what's been happening in a wallet, as an example. But again, we can kind of then expand that out into all of the other elements of how these connect with other people's wallets, where those kind of transactions have moved across boundaries. We use this a lot in the kind of supply chain analysis as well. As you can imagine, there's a lot of fraud when it comes to supermarkets, strangely enough. I mean, when we talk to some of the supermarkets, about 30% of their stock goes missing between source and delivery to the actual supermarket shelves. Blockchains become a lot more prevalent in order to try and track things and how we want to investigate what's going on, where things are going missing, who's involved, where things actually occur, etc. So it's, as far as I2 is concerned, data is just data. We really don't mind where it comes from, what format it's in. If there are, it's all about how you understand the challenges that people are facing and you convert those into questions. So if we want to understand where things have gone missing, where people have been defrauded, what activities people are performing, then these are all the questions, and then we work backwards from there and understand what data we need to provide in order to answer those questions and how we need to model the data to come up with the relevant answers.
Yeah, just to add to this, Vikas ji, hota kya hai ki, the transaction, say Bitcoin has happened, you use something like, say, a wallet explorer or something, and you get a list of all the you either have a transaction ID or you have a wallet ID. So if you have a wallet ID, you hit the wallet ID, put it into your explorer, it will give you a list of all the transactions with the wallet ID. Export them out as a CSV, import it into the analyst note, and find out who's connected, which accounts are more active. Is the money in from this, or is this just a mule account, a temporary account from where the money is flowing out? So
exactly. Yeah, and it doesn't have to be exported to a CSV either. We've actually got connectors which go directly into some cryptocurrency wallets.
Okay, perfect. So that's even better. So you don't really need to export it, just connect it to the wallet and directly get a full listing.
Yeah. So we do similar things with cell phones as well. You don't have to, if you've got something like Celebrite, where you've created a UFED file and you want to see all the contacts and all the apps and the locations where people have been, you can connect directly into it. You want to connect out to an external data set. You want to connect into social media. We've got connectors. And the idea is that we make it easy for the person doing the investigation and the analysis to pull all the data together into a single pane of glass and provide them with tools to quickly identify the answers to the questions that they have.
So the question now is, did this answer your question?
Thank you, sir. Thank you very much. I got the reply.
All right.
I'd like to thank you, Samir, for allowing me to talk on your platform, and I'd like to thank everybody for spending some time with us today. If you've got any questions, obviously go via Samir, or feel free to reach out to me. But thank you very much for your time today.
Thank you. I have one last question here from Professor Anurag Acharya. He wanted to know that sample data which was shown in the demo, do we need to get it from the, do they require an API to pull it from the reserve banking system, or is there something else?
For the Reserve Bank in India, I would have to double check as to what interfaces they provide. But if they have an API, then it would be very straightforward for us to just generate a connector which uses that API to talk to it. If it's a web service, then the connector would just talk that way. In some instances, it may be that they just provide flat files and we generate one of those saved specifications so that each time you receive data, it will normally be in the same format and it will just import it straight away. Yeah. But it really depends as to what interfaces are available, and I'll double check on that one.
Yeah, a common problem here in India is that the data is usually provided as a flat file, and each of the formats are totally different. So I have, my memories are that what we have to do is we have to do some ETL using the I2 platform. And, we love those different features that are there, which allow us to, remove prefixes and add postfixes and things, get it all together into a single format, import them all, and then look for relations between them.
Yeah. But what with depending on the data coming through, I'm currently just building out a little annotator for our new natural language processing platform to read in suspicious activity reports. So it will automatically find accounts and transaction information from flat files without having to do a lot of data manipulation up front. We're trying to make it easier all the time.
Perfect. So if there are no more questions, I will take this opportunity to thank Adrian and thank all of you for the excellent interaction that we've had, for the insights that you've shared with us. Thank you very much. We're all available. Be in touch, and feel free to either get in touch with us over email, WhatsApp, or whichever way you like. Just give us a call. Thank you, and bye-bye. And we will meet next week, same at the Forensic Friday, same place, same time. Have a good week and a great weekend. Bye-bye.